Multitask learning, and this is really a form of regularization. We are looking at learning multiple tasks at once. The idea is we're going to have some body neural network, and it is going to have multiple heads attached. So we are going to then have different kinds of outputs. And I'm an output sum 1 and output sum 2. Y hat sub 1 and y hat sub 2. So we will have training examples which will consist of, let's say, x, y1, and y2. And our loss function is going to be some function that depends both on how y hat 1 and y1 are different and y hat 2 and y2 are different. Let's look at some examples. So maybe what we have is we have an incoming image and our output is a category, what object. So therefore our output is going to be some sort of a softmax. But we also have some sort of a where is it. So we've got an image, it's a person, and we want to know not only it's a person, but also this is the bounding box of the person. So we would have one output, which might be the softmax, and then another output, which is perhaps 4 regressions, top, left, bottom, and right for the bounding boxes. Probably the easiest way to do that is to go ahead and output those in terms of numbers between 0 and 1. So 0 would mean at the top, 1 would mean at the bottom, half would mean halfway through, something like that. But y1 then is a category, and y2 is 4 regressions. Top, left, bottom, right, maybe it's top, left, height, and width, whatever we need to do to obtain this bounding box. And what we find is two things. One, if we wanted to make 2 different neural networks to learn these things, then we're going to get worse performance than if we had one network to learn both things. And that kind of makes sense, because we have 2 networks, and the totality of weights is going to be much larger than a single network with 2 heads. The second thing that's actually somewhat surprising is we get better performance often for trying to learn 2 tasks than to learn 1 task. Okay? Because we've got a beautiful regularization that's coming about. What happens is if you have to learn 2 tasks, your body needs to be more general, right? It needs to focus less on the peculiarities of the particular task and the particular images, and has to more able to generalize. It has to be a more general body because it's satisfying the needs of not just a single head to which it's finely attuned, but multiple heads for multiple tasks. Some examples of this in practice might be, let's say, AlphaGo. Right? They, at one point, had 2 networks. One network that was responsible for deciding what the next move is, and the second network was responsible for predicting, at this point in time, who's most likely to win, white or black. And in later versions of AlphaGo, they went ahead and merged those 2 networks into a single network. And that single network had 2 different heads. One head would decide what's the best action to take, right? And that was just a big softmax of all possible moves. And then the second head was a predictor as to who was likely to win. And that was just a single sigmoid output. But that's kind of how multitask works in terms of adding these new heads. We had talked earlier about multitask learning, but hadn't talked in any particular detail about how actually we make the multitask working. And the way we make it work is we have this single neural network, and then we have just these different outputs on top. When we look at the separate heads here, right, what we can really have is, so we've got these outputs. Let's say here we have a softmax with some number of outputs. And here, let's say it's this example here. So we've got, I don't know, 15 categories. And here we've got a bounding box, so we've got 4 values coming out. We can actually merge these together So the final output, the last layer of our neural network, is really 15 categories plus 4 values. And what that allows us to do is actually say something, y equals model of x. That is, if this is running the neural network, we can feed in and get out a single y, and this single y would have 19 values. And then what we can go ahead and do is calculate the loss, this of course is y hat, the loss of y1 and the first 15 values of y hat. And then also calculate the loss of y2 and 15 on. That is 15, 16, 17, and 18. So we're coming out with a single y hat that we can then break back down into the various y hat 1 and y hat 2. My previous picture actually showed completely separate heads, and in that case it was a little unclear how you would take an x and go ahead and feed it out to the y1 and the y2 without going through the body twice. And we certainly don't want to do that, because when we do our backpropagation, we want to backpropagate one time rather than 2 times. So we create the body, we create these different heads, which are these different mini fully connected networks, and then we go ahead and just combine these the results of these back together. That's it for multitask learning.